Today I'll talk about Lagrange's interpolation. So here is the problem. So I'll solve this problem by using Lagrange's interpolation. The following table gives the values of density of saturated water for various temperature of the saturated stream. So here temperature data is given and corresponding density is also given. Density are also given. Temperature data are given and corresponding density data are also given. So temperature here is 100, 150, 200, 250 and 300, and densities are 958, 917, 865, 799 and 712. Now question number 1 is find the polynomial by using the Lagrange's interpolation formula. Second one, B, find the density when the temperature is 125 degree by Lagrange's interpolation. Again, we have to find what is the density at temperature 125 degrees centigrade. Find the polynomial using polyfit and evaluate the density value for the above temperature. By using polyfit, again the temperature, the density can be calculated at temperature 125 degrees centigrade, and then find the polynomial using Excel and evaluate the density value for above temperature. So last one is we can use Excel and we can do the same job. Now for this problem we must know what is the Lagrange's interpolation formula. So y is equal to fx, and the Lagrangian interpolation formula is x minus x1. So x is, that is which point we want to calculate. X minus x1, x minus x2, dot dot dot, x minus xn, x0 minus x1, x0 minus x2, and x0 dot dot dot, x0 minus xn. Means in that top that will start from x1, means x0 data will not be there, and bottom that x0 minus x0 will not be there. Okay, so that start from x0 minus x1, then x0 minus x2, like that way, and into y0. Similarly, next x minus x0, so x1 data will not be in the top, x minus x2 dot dot dot, x minus xn. Similarly, that subtraction will be other data from x1, x1 minus x0, x1 minus x2 dot dot dot, x1 minus xn. Okay, and like ways we can do that. Now here temperature data. So first data we start from x0, x1, x2, x3 and x4. So x0 is 100, x1 is 150, x2 is 200, x3 is 250, x4 is 300. So corresponding y0 value is 958, y1 is 917, y2 will be 865, y3 will be 799 and 7112. Now we formulate that Lagrange's interpolation formula. So y is equal to fx, so that will be x minus 150, so x minus 150, that is x1, x minus 200, then x minus 250, then x minus 300. Okay, then 100 x0, so subtract all data points. 100 minus 150, 100 minus 200, 100 minus 250, 100 minus 300, 958. So similar way, x minus 100, x minus 200, x minus 250, in the top that x1 is not there here, x1 is not there, x1 is not there, and subtraction will be from x1, x1 minus x0, so 150 minus 100, 150 minus 200, like that. So this is the Lagrange's interpolation formula. Now if we calculate all this, so ultimately if we calculate that value, so Lagrangian polynomial will get x minus 50, x minus 200, x minus 200, x minus 250, x minus 300 by 150 into 10 to the power 6 into this. Now if you do the simplification is not easy, but we can do that. Okay, so we have to multiply x minus 150, then we have to do 5 times. Then we can easily get the polynomial. Now what will be the order of polynomial? What will be the order of polynomial? Now you can see here how many data points are there. So number of polynomial, so number of data points are how many? 5, right? So order of polynomial will be so 5 minus 1. Okay, so if this is n, so that 5 minus 1, so that will be n minus 1. Okay, so now order will be 4. So if 5 data points are given, so order will be 5 minus 1, 4. That you have to remember. So sometime question actually asked what will be the order of polynomial. So order of polynomial will be number of data point minus 1. So that is 4 here. Now that we have to calculate what will be the density at x is equal to 125. What will be the density? X is equal to 125. Now we have to plug x is equal to 125, and then if we calculate, so finally we will get by using Lagrangian interpolation, so that is density is 938.84 kg per meter cube. So that is the density. So at temperature is equal to 1 to 5 degrees centigrade, density will be 938.84 kg per meter cube. So this is the answer. And this answer we got by using Lagrangian interpolation. That's it for that hand calculation. Now I will show the program. In the program, that is MATLAB code. Obviously I will use Octave. So whatever I do in Octave, so same thing if we do in MATLAB, we will get same result, because MATLAB is commercial software, so there is some issue. Because of that I am using Octave. Octave is open source, so that's why I am using. So now I will show you how to do in MATLAB. Okay, now I will show you Lagrangian interpolation code, MATLAB code. So here is the Lagrangian interpolation formula. So y is equal to fx, x minus 150, x minus 200, x minus 250, x minus 300 by so minus 50. So if we go in the basic code, so that will be x minus 150, x minus 200, x minus 250, x minus 300, 100 minus 150, 100 minus 200, 100 minus 250, like that. So this code I'm putting in MATLAB. So this is actually called hard coding. Okay, so this is not a soft coding. Whatever we did in hand calculation, so similar way I'm putting here, and we can easily get the answer. Okay, so here x0, x1, x2, x3, x4 data are given. Then y0, y1, y2, y3, y4 is given. Now we are going to calculate x is equal to 1 to 5. So a1 here, a1 is that denominator. So x0 minus x1, x0 minus x2, x0 minus x3, and b1 is the numerator, x minus x1, x minus x2, and then we are calculating the Lagrangian coefficient L1, L2, L3, L4, and then L5, and then we multiply with y0, y1, y2, y3, y4, and as we are putting all these values, now if I run the program, so we can easily get what will be the answer. Means at x is equal to 125, y will be 938.84. so that we can get that the result. Okay, so this is like a hand calculation method. So now I'm discussing about the code. Okay, so what will be the general that code in MATLAB, right? Now here I'm discussing. So x data actually I'm putting, so you have to give that x data should be given. So 100, 150, 200, 250, 300, and y data is given. Now xi is 125, that x coordinate at which to the interpolate. Now Lagrangian interpolation, so x is the array of x coordinate of the data points, y is the array of y coordinate of the data points, and xi is the x coordinate at which to interpolate. Now first we have to calculate the length of the data points. So how many data points are there? So n is equal to length x. So from that we can easily get the data points. And then result, we are just take a 0, initialize the interpolate value. Then for loop, so that is I is equal to 1 to n, mean compute the Lagrangian basis polynomial Lixi. So L is equal to 1, so when for j is equal to 1 to n, and if j not is equal to I, so that will actually calculate the Lagrangian coefficient. Okay, and then if end and for loop end, and then the result will be the result plus the Lagrangian coefficient into y into that L into y I. So means here, so first Lagrangian coefficient, and then individually yi will be multiplied. Okay, so that's why we'll get the data. So that now here a print is given, so a print density at in particular temperature, so we can easily get the result. What will be the density at particular temperature, what will be the density that we can print, right? Now talking about polyfit, by using polyfit also we can calculate the polynomial coefficient, and then we can use that polynomial coefficient and we can easily calculate what will be the density. Now here that inbuilt function is called polyfit. Now what will be the degree of polynomial? Polynomial, I told you, if there is a n number of data points, so the degree of polynomial will be n minus 1. Now fit a polynomial using polyfit. So coefficient will be polyfit, that is the inbuilt function, x and y data, and degree, you have to mention the degree, right? So evaluate the polynomial at specific x coordinate, and that xi we know means we have to calculate that xi is equal to 125, and what will be the y value, means x coordinate at which to evaluate the polynomial. So y will be yi, we can calculate polyval. Polyval means polynomial valuation, that we have to give that coefficient, and then which at the point when which we want to interpolate. Now that will give that polynomial coefficient, display coefficient, and then a print, we can easily get the result here, that xi and yi, obviously. So yi, so if we run that, we will get the result. If we run that, so here the density at 125 degree centigrade temperature will be 938.8438. so that is this portion, means by that program in the MATLAB. And by using polyfit, okay, so first we are calculating that coefficient. So coefficient will be that minus 2.667 EE minus 0.8, 1.466 e to the power 5 minus, means this is the highest power. This is the highest power coefficient, and then decrease the power of that x, and this is the that free that is like here no, that x to the power 0 means there is a no x, so that value is 999 into 10 to the power 2. So now from here, if we want to calculate the density at 125, so that we will get 938.8437. So now I am showing how to code that, as well as how to use polyfit, and from by using polyfit we can also calculate what will be the density in particular temperature. Now I will show you the Excel. By using Excel, how do you calculate that polynomial coefficient? So using Excel we can do that. So here temperature and density data are given. Temperature and density data are given now. So by using Excel we can easily calculate the polynomial coefficient. Now here first go to the insert and then do the plotting. So we can do the plotting. So chart is that curve or interpolation, interpolation, that is the chart, and this is x title and y title. We can add the x title. X title is temperature, TMP, temperature, and y axis we can put y title also. Y title, where is the y title? Okay, so that is primary vertical, so that is density. Okay, we can do that, density. Okay, now so this is the curve. Now we can use 10 line, and from that we can easily get the polynomial coefficient. So now when we just do that again, so first if we do that 10 line, Control Z. Okay, so if we just click that and right click that add trend line, now here we have to set the polynomial. So polynomial, we have to set the polynomial. Now I told you that if data point is 5, so order will be 4. So here 5 data points are there, so order will be 4, right? That 4, and then here display the equation, and then display r squared value on the chart. If r squared value is nearly 1, so that is best fit. Okay, now already the equation is given here and display the r square is equal to 1. Okay, now Excel, we got the polynomial. So these are the polynomial equation. So now we can increase the font, so that will be okay. So this is the polynomial, so I can increase the font here. Okay, so these are the polynomial, or I can decrease the font size also. Okay, so this is the polynomial, or I can increase the chart area, so then it will be okay. Okay, so these are the polynomial. Okay, now using that polynomial, I can calculate, I mean we can easily calculate what will be the temperature. Now here we can put that x, that is we have to calculate that x is equal to 125. Now we have to calculate what will be the y value. So here I am going to calculate. So y is equal to, now here I am just copying that. Now here that I am pasting, and I am just changing x to the power 4, that is the coefficient. So here I am just putting that cell, okay, cell number, Ctrl Z. Now here is the cell number. Okay, so it will not be good enough, so we have to calculate by manually. Okay, it will not be like that. Okay, so here that is equal, and then we have to put minus 3 e to the power minus 0.8. Okay, and then into x to the power 125 to the power 4, and then plus 1e, okay, minus 0.5, then 125 to the power 3, and then minus 0.0051 into, then again x to the power square, okay, then minus 0.0167 into that x plus 999. Now if you enter, you can see that 929.43 that we are getting. The density is at x is equal to 125. The density is that 929.4 from the Excel. Okay, so earlier what we got from that MATLAB, we got that 938.8437, but Excel we are getting 929.4. Okay, so now I am showing 3 things. So using MATLAB, so if you do hard coding, we can do that. If you do soft coding, the Lagrangian, we can do that. You can use polyfit. By using polyfit, we can calculate the density, and in Excel also, by using Excel, we can also calculate the density 929.4. So these are the way, means you can use the software and you can calculate. We can easily calculate, and we can also do the hand calculation. Thank you.